Hello people, today we are going to start with control cost processes under monitoring and controlling process group. So let's see. Control cost is the process of monitoring the status of the project to update the project cost and managing changes to the cost baseline. The key benefit of this process is that it provides the means to recognize variance from the plan in order to take corrective action and minimize risk. The inputs involved are PM plan, project funding requirement, WPD, OPA. Tools and techniques involved EV earned value management, forecasting, TCPI also known as to complete performance index, performance reviews, PM software, and reserve analysis. The outputs involved are work performance information also known as WPI, cost forecast, change requests, PM plan updates, project document updates, and OPAs updates. So let's see the inputs. First input is PM plan and it contains the cost baseline and cost management plan. The cost baseline is compared with actual result to determine if the change, corrective action or preventive action is necessary. The cost management plan describes how the project cost will be managed and controlled. The next input is project funding requirement. The project funding requirement include project expenditure plus anticipated liabilities. The next input is WPD. WPD includes information about the project progress, such as which activities have started their progress, which deliverables have finished. Information also includes costs that have been authorized and incurred. Next input is OPA. The OPAs include existing formal and informal cost control related policies and procedures and guidelines, cost control tools, and monitoring and reporting methods to be used. Let's learn about the tools and techniques. The first technique is EVM. I have made a tutorial in the past on only on the EVM in detail with examples. So if you want to learn with examples, you can go back to my channel and search for the earned value management tutorial and look on that. So earned value management or EVM is a methodology that combines scope, schedule, and resource measurements to assess project performance and progress. It is commonly used method of performance measurement for projects. It integrates the scope baseline with cost baseline along with the schedule baseline to form the performance baseline, which helps the project management team to assess, measure project performance and progress. It is a project management technique that requires the formation of an integrated baseline against which performance can be measured for the duration of the project. The principle of EVM can be applied to all projects in any industry. EVM develops monitors three key dimensions for each work packages and control accounts, and those are planned value, earned value, and actual cost. So planned value is also known as PV is the authorized budget assigned to scheduled work. It is authorized budget planned for the work to be accomplished for an activity or work breakdown structure component, not including management reserve. This budget is allocated by phase over the life of the project, but at a given moment. Planned value defines the physical work that should have been accomplished. The total value of PV is sometimes referred to as the performance measurement baseline. The total planned value of the project is also known as budget at completion. Next is earned value, also known as EV, is a measure of work performed expressed in terms of the budget authorized for the work. It is the budget associated with the authorized work that has been completed. EV being measured needs to be related to the PMB, and the EV measured cannot be greater than the authorized planned value budget for a component. The EV is often used to calculate the percent complete of the project. Progress measurement criteria should be established for each of the WBS component to measure work in progress. Project managers monitored earned value both incrementally to determine the current status and cumulatively to determine the long-term performance trends. The next is actual cost, also known as AC, is realized cost incurred for the work performed on an activity during specific time period. It is the total cost incurred in accomplishing the work that the earned value measured. The actual cost needs to correspond in definition to what was budgeted in the planned value and measured in earned value. Example, direct hours only, direct cost only, or all cost including indirect cost. The actual cost will have no upper limit. Whatever is spent to achieve the earned value will be measured. Variances from the approved baseline will also be mentioned. First thing is schedule variance, and the next thing is cost variance. Schedule variance, also known as SV, is a measure of schedule performance expressed as the difference between the earned value and the planned value. It is the amount by which the project is ahead or behind the planned delivery date at a given point of time. It is a measure of schedule performance on a project. It is equal to the earned value EV minus the planned value PV. The EVM schedule variance is useful metric in that it can indicate when a project is falling behind or is ahead of baseline schedule. The EVM schedule variance will ultimately equal zero when the project is completed because all of the planned value will have been earned. Schedule variance is the best used in conjunction with the critical path methodology, CPM, scheduling, and risk management. Equation is given by SV is equal to EV minus PV. Cost variance. CV is the amount of budget, deficit, or surplus at a given point in time, expressed as the difference between the earned value and the actual cost. It is a measure of cost performance on a project. It is equal to the earned value minus the actual cost AC. The cost variance at the end of the project will be the difference between the budget at completion BAC and the actual amount spent. The CV is particularly critical because it indicates the relationship of physical performance to the cost spent. Negative CV is often difficult for the project to recover. Equation will be given by CV is equal to EV minus AC. The schedule variance and the cost variance value can be converted to efficiency indicator to reflect the cost and schedule performance of any project for comparison against all other projects or within portfolios of the project. The variances are useful for determining project status. The next thing is Schedule Performance Index, also known as SPI, is a measure of schedule efficiency expressed as the ratio of earned value to planned value. It measures how efficiently the project team is using its time. It's sometimes used in conjunction with the Cost Performance Index, which is also known as CPI, to forecast the final project completion estimates. An SPI value less than 1 indicates less work completed than was planned. SPI greater than 1 indicates more work was completed than was planned. Since the SPI measures all the project work, the performance on the critical path also needs to be analyzed to determine whether the project will finish ahead of or behind its planned value finish date. The SPI is equal to the ratio of EV to the PV. So equation is given by this: SPI is equal to earned value divided by planned value. Next thing is Cost Performance Index, also known as CPI, is a measure of cost efficiency of the budgeted resources, expressed as a ratio of earned value to the actual cost. It is considered the most critical EVM metric and measures the cost efficiency of the work completed. A CPI value of less than 1 indicates cost overrun for work completed, and the CPI value greater than 1 indicates cost underrun of the performance to date. The CPI is equal to the ratio of earned value divided by actual cost. The indices are useful for determining project status, and providing a basis for estimating project cost and schedule outcome. Equation is given by EV divided by AC. The three parametric plan value, earned value, and actual cost can be monitored and reported on both period by period basis, typically weekly or monthly or on a cumulative basis. So this figure uses S curve to display earned value, uh, earned value data of the project that is performing over budget and behind the schedule. So here we can see that this is the planned value PV, and then this is the middle line is the planned value. This one is earned value, and the uppermost is the actual cost. So here we can see that the actual cost is more than the planned value. So actual cost is more than the planned value. So we can say that this project is performing over budget. And here we can see that the project was supposed to complete here, but it is still going to end. Estimate at completion gives the actual end date. So we can say that the project is behind the schedule. The next technique is forecasting. As the project progresses, the project team may develop a forecast for the estimate at completion, that is known as EAC, that may differ from budget at completion based on the project performance. If it becomes obvious that the BAC is no longer viable, the project manager should consider the forecasted EAC. So here we can see that initially it is always budget at completion. This is the line where this is the time where the project should be completed. But at some point of time, when project manager realizes that it is no longer viable, then they calculate the EAC, estimate at completion. Forecasting the EAC involves making project projections of conditions and events in the project's future based on the current performance information and other knowledge available at the time of the forecast. Forecasts are generated, updated, and reissued based on the work performance data that is provided as the project is executed. The work performance information covers the project's past performance and any information that could impact the project in the future. The EACs are typically based on the actual cost incurred for the work completed plus an estimate to complete, that is also known as ETC, the remaining work. It is incumbent on the project team to predict what it may encounter to perform the ETC based on its experience to date. The EVM method works well in conjunction with the manual forecast of the required EAC cost. The most common EAC forecasting approach is manual bottom-up summation by the project manager of the project team. The project manager's bottom-up EAC method builds upon the actual cost and expenses incurred for the work completed and requires new estimate to complete the remaining project. So estimate at completion is the actual cost which we have incurred so far plus bottom up estimate to complete from that point of time. The project manager's manual EAC is quickly compared with the range of calculated EAC representing various risk scenarios. When calculating EAC values, the cumulative CPI and SPI values are typically used. While EVM data quickly provide many statistical EACs, only three of the more common methods are described as well. So first method is EAC forecast to ETC work performed at the budgeted rate. Excuse me. This EAC method accepts the actual project performance to date, whether favorable or unfavorable, as represented by the actual cost, and predicts that all future ETC work will be accomplished at the budgeted rate. When actual performance is unfavorable, The assumption that the future performance will improve should be accepted only when supported by the project risk analysis. Equation is given by EAC is equal to actual cost plus budget at completion minus earned value. Next method is EAC forecast for estimate to complete work performed at the present CPI. This method assumes that the project has experienced to date can be expected to continue in future. The ETC work is assumed to be performed at the same cumulative cost performance index as that incurred by the project to date. An equation is given by EAC is equal to BAC divided by CPI. The next method is EAC forecast for ETC work considering both SPI and CPI factors. In this forecast, the ETC, that is estimate to complete work, will be performed at an efficiency rate that considers both cost and schedule performance indices. This method is most useful when the project schedule is factor impacting the estimate to complete effort. Variations of this method might method weigh the CPI and SPI at different values. Example 80-20, 50-50 or other ratio. According to the project manager's judgment, equation is given by EAC is equal to AC plus BAC minus EV divided by CPI multiplied by SPI. Each of these approaches is applicable for any project and will provide the project manager team with an early warning signal if the EAC forecasts are not within the acceptable tolerance. The next technique is to complete performance index, also known as TCPI, is a measure of the cost performance that is required to be achieved with the remaining resources in order to meet a specified management goal, expressed as the ratio of the cost to finish the outstanding work to the remaining budget. TCPI is calculated cost performance index that is achieved on the remaining work to meet specified management goal, such as BAC or the EAC. If it becomes obvious that the BAC is no longer viable, the project manager should consider the forecasted EAC. Once approved, the EAC may replace the BAC in the TCPI calculation, and the new equation based on BAC will be BAC, which is budget at completion minus earned value, whole thing divided by BAC minus AC. The equation of the TCPI is then shown in the lower left as work remaining defined by BAC minus EV divided by the funds remaining, which can be either BAC minus AC or BAC minus the AC, EAC minus AC. If the cumulative CPI falls below the baseline, all future work of the project will need to be performed immediately in the range of the TCPI BAC. So here is it is explained in the top line of this figure to stay within the authorized BAC. Whether this level of performance is achievable is a judgmental call on a number of considerations, including risk, schedule, technical performance. This level of performance displayed as the TCPI or EAC line. The equation of the TCPI is based on the BAC minus EV divided by EAC minus AC. Basically, work remaining divided by funds remaining. Funds remaining can be given by two formulas, and work remaining can be given by one formula. And this ratio is known as TCPI, also known as to complete performance index. Performance reviews is the next technique. The performance reviews compare cost performance over time, schedule activities or work packages overrunning and underrunning the budget, and estimated funds needed to complete work in progress. If earned value management is being used, the following information is determined. The first thing is variance analysis. Variance analysis, as used in EVM, is the explanation, cause, impact, and corrective action for cost. CV is equal to EV minus AC. Schedule SV is equal to EV minus PV, and variance at completion, that is VAC, is equal to BAC minus EAC, is the variance. In the graph, we remember that this was the initial estimate BAC. When project management decided that it is not going to fulfill this requirement, they calculated the ETC, which is in addition estimate to complete after this one from the actual cost incurred. So this is the final estimate at completion, which we saw in the past picture. Cost and schedule variance are the most frequently cost and schedule variances are the most frequently analyzed measurement for projects not using earned value management. Similar variance analysis can be performed by comparing planned activity cost against the actual activity cost to identify variances between the cost baseline and actual project performance. Further analysis can be performed to determine the cause and the degree of variance relative to the schedule baseline and any corrective or preventive actions needed. Cost performance measurement are used to assess the magnitude of variations to the original cost baseline. The next technique is trend analysis. Trend analysis examines the project performance over time to determine if the performance is improving or deteriorating. Graphical analysis techniques are valuable for understanding performance to date and for comparison to future performance goal in the form of BAC versus EAC and completion dates. The next technique is earned value performance. It compares the performance measurement baseline to actual schedule and cost performance. EVM is not being used, then the analysis of the cost baseline against the actual cost of the work performed is used for cost performance comparison. So next technique is project management software is often used to monitor the three EVM dimension PV, EV and AC to display graphical trends and to forecast the range of possible final project results. The next technique is reserve analysis. During cost control, reserve analysis is used to monitor the status of contingency and management reserves for the project to determine if these reserves are still needed or if additional reserves need to be requested. As work of the project progresses, these reserves may be used as planned to cover the cost of risk mitigation events or other contingency. Or if probable risk events do not occur, the unused contingency reserves may be removed from the project budget to free up the resources for other projects or operations. Additional risk during the project may reveal a need to request that additional resource be added to the project budget. The output is WPI or work performance information. The calculated CV, SV, CPI, SPI, TCPI, and VAC values for the WBS components. In particular, the work packages and control accounts are documented and communicated to stakeholders. The next output is cost forecast. Either a calculated EAC value or the bottom-up estimated completion value is documented and communicated to stakeholders. Then the change request analysis of the project performance may result in the change request to the cost baseline or other components of the project management plan. Change requests may include preventive or corrective actions and are processed for review and disposition through the perform integrated change control process. Then there is PM plan updates, which updates cost baseline and cost management plan. Changes to the cost baseline are incorporated in response to approved changes in scope, activity, resource, or cost estimate. In some cases, cost variances can be so severe that a revised cost baseline is needed to provide a realistic basis for performance measurement. Changes to the cost management plan, such as changes to the control threshold or specified levels of accuracy required in managing the project's cost, are incorporated in response to feedback from relevant stakeholders. Then project document updates include cost estimate and basis of estimate. Then OPS update include causes of variance, corrective action chosen and the reason, financial databases and other types of lesson learned from the project control cost control. So guys, I hope you got some idea on what is control cost processes and how to deal with them. So subscribe to my channel or come back to my channel for more videos on PMP and other things. Thank you so much for watching. See you soon.